Hello everyone, this is Mohammad Said Nabar Prohor back again with another video. So our today's session is on Seaborn, which is a statistical data visualization library for Python. So as you can see that Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. So this is the website for Seaborn and pydata.org, and here you can find the API, gallery, tutorial, then releases. Yeah, pretty much it. So today I'm gonna show you six types of use of Seaborn, which is scatter plot, histogram, box plot, line plot, bar plot, and last heat map. So let's move on to what is Seaborn. Seaborn is a Python data visualization library built on top of Matplotlib. So it uses the basics of Matplotlib, but it is itself a different library. It provides a high-level interface for drawing informative statistical graphics. Let's dive into some examples. So, at first, we're gonna see how to create a scatter plot by using Seaborn. So, it is used to visualize the relationship between two variables. A scatter plot, example, a dataset containing information about students' study hours and their exam scores. So here, I'm gonna import Seaborn as SNS and import matplotlib.pyplot as plt. So we are gonna hold two variables, which is two lists containing sample data. One is study hours and another one is exam scores. So we're gonna create a relation between these two by showing you the scatter plot between these data. So to create a scatter plot, we're gonna use sns.scatterplot function. As I said earlier, that C1 has its own scatter plot. So the X line is study hours and the Y line is exam scores. So then I'm gonna label it by using PLT. X label is study hours and Y label exam scores, and the title would be study hours versus exam scores. And now if I show the graph or run the graph, it should show a scatter plot between the relation of this data. As you can see that my X label is study hours and Y label is exam scores, and 80, 75, 70, 65, 60, 50 are the scores, and 2 to 8 are study hours. As you can see that people who studied for 2 hours got exam 55 in the exam. So more the hours, more the scores. And this is the scatter plot by using Seaborn. Now moving on to the histogram. The histogram is used to visualize the distribution of a single variable. The scatter plot was the relation between two variables, and this is the distribution of a single variable. So now for histogram, we will use the data set containing ages of people. So at first I'm going to take a list of ages from 25, 35, 35, 40. Then I'm going to use sns.histoplot and then use the ages variable there, and the beans is a string which is 5. Then I'm going to label x as age, then y as frequency, and then title will be age distribution. So now if I run the code or create or show, as you can see that this is the distribution of a single variable, and the frequency is written here. As you can see, the 30 appeared 3 times, 40 appeared 2 times, 50 appeared 2 times, 60 appeared 2 times, and 80 appeared, or 70, 80 appeared 3 times. And moving on to the box plot, it is called a box plot or whisker plot. It is used to visualize the distribution of a continuous variable and to compare distributions between different groups. Example, a dataset containing exam scores of a student from two different classes. So class A have this course and class B have this course. Then we're gonna use sns.boxplot. Then the data would be in a list, and the width would be 0.4. And then x ticks is class N class B, and Y label is exam score. As there are two data, that's why we're gonna use 2 and x ticks rather than x label. Now the title will be exam score distribution by class. Uh, Now by running the code, you will see the box plot or the whisker plot. As you can see that our x ticks there are two, class A and class B, and this is the exam score distribution by class. And this is called a whisker plot or box plot, whatever you are comfortable to mention. Then moving on, a line plot. It is used to visualize the trend of a variable over time or any other continuous variable. For example, dataset containing temperature over a week. So as always, we're going to use both Seaborn and Matplotlib, and the sample data would be days of a week, and then the temperature was throughout the week. So for this, we're going to use sns.lineplot, and x would be days, y would be temperature, and marker would be 0 or small letter o. And the label would be days and temperature, and then title would be weekly temperature trend. Now, I'm going to use x ticks to rotate x axis label for better readability. It helps to understand the label more clearly, because as you can see that Monday, Tuesday, Wednesday is a very long variable. So if it is rotated through the x-axis, it can be read perfectly. Now if I run the code, as you can see that this is the line plot for our weekly temperature trend, and these are the temperatures throughout the week, and these are the days. As I said earlier, that Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday is a very long line. So to hold the line carefully, I rotated the days by 45 degrees. So it helped to fit those lines in my X level. And as you can see that the visualization of Seaborn is very good than Matplotlib, and it helps us to create a good distribution table for single variable, continuous variable, or double variable. Now moving on to bar plot. It is used to visualize the distribution or comparison of categorical variable. So as same as always, we're gonna use Seaborn. Then the sample data would be fruits of different types, and the quantity is sold. Now we're gonna use sns.bar plot, and x would be fruits and y would be quantity sold. Then I'm gonna label the x and y and the title. Now if I show the plot, uh, very basic, right? Apple, banana, orange, grapes. Apple sold 50 times, banana sold 70, then oranges sold 60, and grapes sold around what, 45. So very basic codes, and it is mainly used for to visualize our data in our machine learning algos, because when we visualize our data, we can understand the algorithms very clearly, and we can understand that how our algo works with the real life data or big data, right? That's why we need visualization rather than showy thing. Okay. Then moving on to the heat map, it is used to visualize the matrix like data where the values are represented by colors. So it can be also used to show correlation between data. Now, as you can, as I said earlier, that it is a matrix data. That's why we also need NumPy, and we're gonna generate a correlation matrix by using Seaborn, Matplotlib, and NumPy. At first, we're gonna use a random seed from NumPy. Then, for data, we're gonna create a 5 by 5 matrix, and for the correlation matrix, we're gonna use core coefficient by using the data which we created randomly by using random.rand. Now for creating a heat map, we're going to use sns.heatmap, and then give the correlation matrix variable, then anode equal to, it's the parameter, and then CMap equal to coolworm. So by using the coolworm string here, I'm commanding my heat map to be the color of from cool to warm, so like from blue to red. Now the title will be correlation heat map, and if I run this, you can see, yes, as I said earlier, from cool to hot. So this is the correlation data of a 5 by 5 matrix. The data given randomly here, as you can see, 0 to 4, 0 to 4, 1 to 4 is highly correlated, 4 to 4 is highly correlated, then 0 to 0 is highly correlated, but 0 to 4 is less likely to correlate it, which is why it is shown in a color that it is less correlated. 3 and 4 is less correlated, but 2 and 4 medium correlated, 1 and 4 is more or less correlated, and 0 is more likely to correlate than 1. So this is a correlation heat map, and this was the basis of Seaborn. By using Seaborn, you can visualize like all types of data visualization from our statistics and graphics. It is also used highly in data science, also in machine learning, also in AI. So yeah, that was it. I'm gonna come back with another video later. Thank you for staying with me.